There's been some questions about the polypeptide question that make me think that I should probably get a little bit more detailed about how you make a polypeptide. And so I'm going to use doceria again to do that, and we'll see how this goes. But basically what's going on when you make a polypeptide is that you have 2 amino acids. So I'm just going to draw them here very badly. Oh my gosh, that looks terrible. Okay, and then that's the R group, and it doesn't matter what it is. And of course we have the NH2. And we're going to have another amino acid. That's a better way of doing it. With the hydroxyl and a carbonyl and an R group. So this is R1 and this is R2. Okay, now we're going to make the polypeptide. So remember that you've got the carboxylic acid over here. You've got the oxygen of the carboxylic acid, and you've got the nitrogen of the amino terminus. And what happens is that these 2 groups will come together. All right? Let me erase my markings. So you've got a lone pair of electrons on the oxygen, right? Those are going to come over and attack the nitrogen. And in so doing, what's going to happen is that water is going to come off. I'm going to lose the entire hydroxyl on this side. I'm going to lose one of these hydrogens. Okay? So water is going to come off, and I'm going to be left with N to another N, and just for ways of getting things goofy, I'm going to make it a little complicated. And then R2, and we will still have the carbonyl, of course, and R1. Okay? So, what we had before was we had a dissociating proton here. Aha. We had a dissociating proton here, and we had a group that could accept another proton. So these 2 groups could have been charged had they been free. But when we make the polypeptide, they're not free. This is the peptide bond being formed. The carbonyl is from the carboxylic acid. The nitrogen is from the amine. And now you guys see why I was a B student, because I forgot my proton. See that? That's what's really supposed to be like that. So does that make sense? That these 2 charges here, the 2 groups that could be charged, your carboxylic acid and your amine, disappear into your peptide bond. So you never take into account those things. You take into account the R groups on your amino acids, and you take into account the amino terminus. So we'll just put charges on this. We'll say that everybody's really acidic, so we have a positive charge on our amino terminus. On our carboxylic acid terminus, it's neutral. Okay? And that's my biggest point, was that people were talking about the charges on the termini of each amino acid. You don't have the termini. You have a peptide bond now. Hope this helps.